lesson 33. Can you believe it? We are already 33 lessons in. You guys have been doing great. Today we're going to talk about rounding numbers and estimating. Rounding numbers and estimating. So go ahead and put lesson 33 notes at the top of your paper and today's date. And let's go ahead and get started. All right, let's go ahead and skip over our counting up. Mental math. Go ahead and pause your screen here. Let me move my picture out of your way so that you can see all of the words. All right, there we go. So, how many months are in half of a year? And a year and a half. Those are two separate things. So there's A and then part A of A. All right, and then B, how much money is 4 quarters? How much money is 5 quarters? How much money is 6 quarters? The cost of one video game is $42. What is the cost of 10 video games? All right, and then D, 50% of 40. E, 25% of 40. F, 10% of 40. G, the regular price is $8.40. If the item is on sale for $1.40 off, what is the sale price? And then lastly, 8 times 8 minus 1 divided by 9 times 3, 11, and divided by 4. All right. That 11 seems odd to me. Let me check that out for you. Oh, it should say minus 1, not 11. Minus 1. Let me fix that here on the screen for you. So ignore this, and it's a minus 1. That makes much more sense. So 8 times 8 minus 1 divided by 9 times 3 minus 1 divided by 4. And that should get you your right answer. All right, and let's check our answers right now together while we're here, okay? Let's make sure we're all on the same page and we're understanding what we're doing. All right, so how many months are in half of a year? How many months are in half of a year? That would be 6 months, and then a year and a half would be 18 months. So 6 months, and then a year and a half would be 18 months. Remember, when we're writing out math, we still need to include what we're talking about. Okay, so make sure you put months in there. How much money is 4 quarters? Or another way of asking that is, how much does 4 quarters equal? That would be what? $1. $1. How about 5 quarters? Remember, a quarter is 25 cents, so 5 quarters would equal $1.25. 6 quarters, we're going to add 25 cents more, right? So now we have $1.50. The cost of one video game is $42. What's the cost of 10 video games? So to figure this out, you need to multiply 42 times 10. So you get 420. $420. Don't forget your dollar sign like I just did. $420. Okay. 50% of 40. That's another way of saying half of 40. So half of 40 or 50% of 40 would be 20. What about 25% of 40? 25% of 40 or 1/4 of 40 would be 10. Okay. And 10% of 40 would be 4. The regular price is $8.40 if the item is on sale for $1.40 off. What is the sale price? That means you need to subtract $1.40 from $8.40. So your new sales price would be $7. Not $700, $7. Okay. And then for H, you should have got the answer to be 5. All right. Great work. Let's move on. Here's our power up problem solving. Julio, or Julio, Julio identified a pattern in lunches served at the school cafeteria. He found that macaroni was served as part of lunch, or part of every 8th lunch. Part of every 8th lunch. If macaroni was served on a Friday, what are the next 2 days of the week Julio can expect macaroni to be served? School is in session only Monday through Friday with no holidays, okay? So first we need to know what information are we given. That's part of understanding. So what kind of information are we given, and then what are we asked to do? Let's underline the information that we're given, okay? You can write it down. I'm going to underline it here because I don't have as much space to work with. Okay, he identified a pattern. Okay, that's a piece of information that's good to know. He found out that macaroni was served every 8th lunch. And if macaroni was served on a Friday, okay, then the next thing that they ask us is, what are we asked to do? We need to figure out what are the next 2 days of the week that Julio can expect macaroni to be served. Okay, you can find all that information right there. And then there's another important piece of information, right? School is in session Monday through Friday with no holidays. All of that is super important. If we don't know that, we can't really solve our problem, okay? So now we know the good information and we know what we're asked to do. We need to figure out when macaroni will be coming up on the school lunch calendar, okay? All right. What kind of problem solving could we use to solve this problem? Well, we need to extend the pattern, right? If we know that it was served on a Friday, then we need to extend our problem. So how could we extend the problem? Well, we can list the school days, right? So let's go ahead and do that. And then we will find out what the 8th and 16th days are after Friday. So let's start our list with Monday because that's the first day after Friday. Okay, so the next possible school day would be Monday. So we'll do a 1, and then Monday, I'm just going to do the abbreviations. 2, Tuesday. 3, Wednesday. 4, Thursday. 5, Friday. Okay, now we know that it does not count on Saturday or Sunday, right? Because it says Monday through Friday. So then our next day, 6, would be Monday again, Tuesday, and then there's our 8th day, Wednesday. Okay? Now, we want to remember that day because that's the every 8th day, right? So we're going to make it bold so that we remember that we found our answer is Wednesday. But we are not quite done yet, right? We need to find out the next 2 times it's going to be served. So let's make our next column start up here just to keep things nice and organized. And the next day after Wednesday would be the 9th day. And that's going to be Thursday. Then the 10th day would be what? Friday. Oh, why did they do that? Thursday. Then why does it keep doing that? It's not okay. Friday. 11th day would be Monday, right? Because we skipped the weekend. 12th day Tuesday, 13th day, Wednesday, 14th day, Thursday, 15th day, Friday, and then 16th day would be Monday. And let's go ahead and make that bold again so we remember that that's our answer. Okay, so now we found the next 2 days. So we would write our answer Wednesday and Monday. All right, Wednesday and Monday. All right. Then we always want to make sure that our answers make sense. So we might want to go back and look at our work and make sure that we didn't miss any days and we did it right. We did, so we are good to go. All right, moving on. Today, our new concept. When we do not know the exact amount to describe a situation, we can round numbers to a specific place value. Numbers that have been rounded usually end in one or more zeros. Okay, numbers that have been rounded usually end in one or more zeros. When we round a number, we find another number to which that number is near. One way to do that is with a number line, like you can see here on the screen. Okay, so if we said our number is 67, which would be closer, the 60 or the 70? Obviously, the 70 would be closer. So 67 rounded would be 70. Let's look at this picture below to get a better idea. This is called the rounding coaster, okay, like a roller coaster. To the nearest hundredth or to the nearest 10. So if we're rounding down, it's before we get to the 5. Okay, and if we're rounding up, it's after you get to the 5. Find the number and then look right next door. 5 or higher adds one more. 4 or less, let it rest from the arrow on, change to zeros. Okay, so if our number is 462 and we're rounding to the nearest 500 or nearest hundredth, then we're going to look at this number that we're rounding, which is the hundredth place, right? The 4. If it's less, you're going to go down. You're going to look at the next number over. Okay, so we're rounding to the hundredth, but you're looking at the next number over. See where it says look right next door? So you're going to look at the 6. If the 6 is more than 5, then you're going to round up the 100 to 500. If it was 42, then you would go down and you would say 300. Okay, so when we're rounding to the nearest hundredth, you're actually going to look at the 10 space, okay, to tell you which way to go. And if the 10 space is bigger, 5 or bigger, then you're going to go up. And if the 10 space is lower than 5, so 4, 3, 2, or 1, then you're going to round down, and then you're going to change the hundredths place. Okay, if you're rounding to the nearest 10, then you're going to look at the 6, but you're going to look at the 2 to change it. Okay, so if we're just going to change this time, if the number was 462, 2 is less than 5, so we're going to round down. Okay, so then it becomes 460. But if it was 466, then we would round up and it would become 470. All right. Example 1. Let's try this one together. Write down in your book. Example 1. We're going to round 523 to the nearest hundredth. Okay, so that means according to the chart we just looked at that we want to change the 100 spot, but to do that we're going to look at the 10 spot, right? So is 2 greater than or less than 5? It is less than, right? So then our 5 is going to change to a 4, and then everything else is going to change to zeros because we're rounding to the nearest 100. So we're no longer worried about these numbers here. We're saying these are less than, so we're going to make them into zeros. Let's try, we'll try some more in a little bit. So we sometimes use estimation or we use rounding to find an approximate value, okay? So if we don't need to know exactly, but we just need an idea of what we're talking about, we call that an estimate. And we find the approximate value, what it almost is. We round numbers close to a number given number. So let's estimate, okay? If we have 199 and we were rounding to the hundredth, what would this be? What would this 199 change to? It would change to 200, right? Because 9 is greater than 5. And then that 1 becomes a 2, and we make the other ones zeros. And then what about 200? We're still rounding in the hundreds, and the 0 is definitely less than 5. So then that becomes, we're going to leave it at 200. It does not change, okay? It's not going up. It's just going to stay the same, okay? And then we can add them together and get 400. Now, the reason this is a good tool is because if you're doing a complicated math problem and you want to check your work, you could estimate to figure out what your answer should be close to. So then when you look at your answer, if it's not anywhere close to that, you know you did it wrong. Okay, so if you did this problem and you got something like 600, but you had already estimated to find out that the answer should be close to 400, then you would know that you did this problem wrong. Okay? Or if you got the answer to be 200 or 300, you would know that's not really close to 400, so something in your math went wrong. Okay? It's a good tool to help you do quick math to figure out if your real math is correct or not. Here's example 2. In a presidential election, each state is assigned a certain number of electoral votes. This is in the United States. Based on the 2000 census, the state of Florida was assigned 27 electoral votes, and the state of Texas was assigned 34 electoral votes. About how many electoral votes can a candidate win altogether in those situations? Okay, when it says about, then they're asking you to estimate. Okay, about is saying that they don't need the real number, they're just asking you to estimate. Okay, so about how many electoral votes can a candidate win altogether in those states? So if we look at 27 and we need to change our tens place, we look at the 7 and it's greater than 5, so the 2 becomes a 3 and we say that this is 30. And then we look at 34 and it's less than 5, so we leave it and it stays 30. Because remember, if it's less than, it stays the same. You don't change it, it just stays the same. Oh, that should be a 0, not a 6. Okay. Just go with me there. There we go. So then we would say about how many would be 60 votes. Okay, that's our estimation. That's telling you about how many. That is not the actual number that they need, but it's more or less what they're going to need if they want to win all of the votes in those 2 states. Okay, 60 votes. The real number, we would have to just add 27 plus 34. Okay, but we're not looking for the real number because it asks us about. Okay, that's your key word. So you need to be paying attention in your problems. If it asks you about, then it's asking you to make an estimation. Let's try a different one. The average depth of East China Sea is 600 120 feet. The average depth of the Yellow Sea is 121 feet. To the nearest 100th feet, how many feet deeper is the average depth of the China Sea? Okay, to the nearest 100th. So we're going to change our 100th place this time, not our tens, to the nearest 100th. So this one is 2 less than 5. Yes, it is. So 6 stays the same, and it just goes to 600. We take out the 2 and we make it a 0. So we have 600 as our first number. That's the East China Sea. And the Yellow Sea is 2 less than 5. Yep, still is. So that just stays at 100. Okay, and now you can see why this is so much easier than doing the real math is because we're only going to really have to do this, right? So to the nearest 100 feet, about how many, there's our keyword again, about how many feet deeper is the average depth of the East China Sea? So we just do some subtraction and we get 500. 500, and we'll put the little symbol for feet. Okay, 500 feet. All right, let's move on. Example 4. A community theater group is giving 4 performances of a play. The theater can seat 424 guests. 424 guests, let's underline that. All of the tickets for each performance have been sold. Estimate the total number of guests who plan to see the performances by first rounding the number of guests for each performance to the nearest 100th. Okay, so they're giving 4 performances. All the tickets have been sold, and there's 424 seats, right? So we're going to round to the nearest 100th, they said. So we want to change this number or leave it the same. That's what we're figuring out. And we need to look at the 10 space to do that. And we already said before that 2 is less than 5. So 4 stays the same, and these become 0. Okay, so 400, right? And there's how many performances? 4. So we're going to do 400 times 4 to get our answer. Okay, and 400 times 4 gives us 1600 because 4 times 4 is 16, and then we just add the 2 zeros at the end. Okay, 1600 guests. Sorry about my writing here. It's hard to do this on a touchpad. Okay, 400 times 4 equals 1600 guests. All right. Compatible numbers. Compatible numbers are numbers that are easy to compute. When estimating, it is not necessary to use numbers rounded to the nearest 10, 100, or 1,000. Example, you could do 4 times 4, 25, or 4 times 400, or 4 times 25. Okay? Results in a number that is close to the exact answer. So if we did 4 times 4, 25, we just rounded that last number up to a 5 to make it simpler, right? If we did this one, we rounded to the 100th. And if we did this, we're only doing the last part of the answer. Let me turn my page here, make sure we got all that. So 4 times 425 would be 1700, right? And 4 times Oh, sorry. That is not what I meant to write it down here. 1700. Let me erase and get my writing tool out because it's so much easier. Just a second there. Okay, so here we go. 4 times 400 is 1700. All right, and 4 times 25 gives us 100. So then we could add those together and say 4 times 425 . I'm sorry, you guys. I'm having a hard time here. 1600. There we go. 1700 is up here. All right, there we go. 4 times 425 is 1700. 4 times 400, if you break it down, is 1600. 4 times 100, or 4 times 25 is 100. So in this case, you could do sorry, ignore this 4 here. Let me get that out of the way. Okay, you could do 1600 plus your 100 to get that number at the top, the 1700. Okay, that's what I was trying to tell you, but it's different in my book than up here on the screen. There we go. All right, so you could add your 2 bottom numbers to get you an estimate of your top number, okay? And then you're only going to be off by a little tiny bit, okay? So you can break down your problem using estimation. Example 5, let's see. Layla's car traveled 129 miles. Okay, let's get our little drawing tool out here. She traveled 129 miles and used 4 gallons of gas. About, okay, there's our keyword, so we know we're estimating. How many miles did the car travel on each gallon? Okay, it says use compatible numbers. Okay, so what we want to do is we're going to use, instead of changing 129 to 130, we're going to change 129 to 128. Okay, and then we're going to change, and then we're going to divide it by 4. Okay, because 4 goes into 128 really easy, right? So then we're going to divide by 4. And then that is going to give us an answer that is super easy, 32, right? So we can say about 32 gallons. Okay, so we just got rid of that one little number that was making this whole problem tricky. And by doing that, we made it a simple problem. Okay, we use compatible numbers because 4 goes into 128 much easier than 4 going into 129. Okay, that's how we do that one. Okay, let's practice together. We're going to round to the nearest 10. Okay, let me make this font size a little bigger for this one. Okay, so if we're rounding to the nearest 10, remember then that we are looking at our 1 space, not our 10 space. Okay, so we're going to look at these numbers that are underlined in red to determine if we're going to go up or leave it the same. Okay, that's what we're trying to figure out. So 72, the 2 is less than 5. So on that roller coaster, we're going to go down and leave it the same. So it becomes just 70. Okay, we don't drop it down to a different number, but we leave it the same. Okay, 87, the 7 is greater than 5. So now we're going to round up to 90. 49, the 9 is greater than 5, so we're going to round up again to 50. And 95. Now it seems like it's smack in the middle, but remember if it's 5 or greater, we're going to go up. Okay, we're going to give it the benefit of the doubt, so to speak. So we're going to go up to 100. Okay, great job. And Let's go to the nearest hundredth. This time we're looking at the 10 space, remember? Even though we're going to change the hundredth, we're going to look at our 10 space to determine what our hundreds is going to be. All right, so 685, we're looking at the 8. The 8 is greater than 5, so then the 6 becomes a 7, and we make 2 zeros. Take over these places here. Okay, we're saying 600 is and 85 is closer to 700 than it is to 600, right? You could also think if it's more than 50, when you're looking at 100, if it's more than 50, then you're going to go up to the next 100, right? That's what you're really doing. All right, so 420 is less than, right? Less than 5, so you're going to just leave it at 400. Okay, we don't drop it down because that would be too big a drop. We just go down to we leave it at 400. 776, 7 is more than 5, so we're going to go up to 800. And 350 is 5 or greater, so we're going to go up to 400. All right. Let's continue. A row of bleachers in a gymnasium can seat 96 people. Okay, 96. Now, estimate, oh, they didn't even say about, they just flat out told us this time, estimate the total number of people who can be seated in 8 rows and explain your reasoning. Okay, so we're going to estimate. So we're going to change 96 to what? Good, we're going to change 96 to 100, right? Because the 6 is greater than 5, and 96 is almost 100. So we're going to go 100. And then there's 8 rows. So we need to multiply 8 times 100, and that gives us 800. And then this is the key part that some of you miss. Okay, don't miss this when you're doing your work. Explain your reasoning. That means you need to tell me how we know that this is true. Okay, so you need to say why we did this. We did it because 96 is almost 100, and there are 8 rows. Okay? Does not have to be complicated, but if it says explain your reasoning, then you need to take the time to do that. In their Major League Baseball careers, Lou Gehrig hit 493 home runs. Underline that number so we don't lose it. 493 home runs, and Frank Robertson hit 586 home runs. About, there's our key word again, about how many home runs did those two players hit altogether? Well, 493, we know we're going to round up, right, to 500 because it is almost 500. The 9 is greater than 5. And then Frank hit 586, and 8 is higher than 5, so that's going to go up to 600. And we need to add those two numbers together. So 5 plus 6 equals 11. And we need to add our zeros. So all together, they hit almost or about let's do in front of almost, oh my goodness, 1,100 home runs. Okay, almost 1,100 home runs. We'll put our comma in there to make it look even nicer. Okay, there we go. Okay. All right, we are almost done here. Let's see what's left. Our homework for today. Our homework is on page 209 and page 210. 1 through 30, and you're only going to do the even numbers. Okay, even numbers only, pages 209 through 210. All right, you guys, great job today. Thanks for watching, and I will see you in class. Bye.